Hello everyone, I am Kalpana and today I am going to explain next questions of DS assignment. Write a program. Question number 8 is write a program in Python to implement logistic regression and linear regression for every method. Compute and display the implemented models evaluation measures whichever is applicable, such as accuracy and other values of different evaluation matrices, such as confusion matrix, accuracy, precision, recall, F1 score, and specificity and location function, RMSE and R2 score. So complete Python program is here. For this, we first have to uh, import the NumPy library from Python, and after writing this, you can see here init. So what is init doing? First we set learning rate and number of training approach using init. After inside fit, we calculate the prediction using a simple dot product between x and theta. After it, we find the error and compute the gradient. After it, we update theta in every approach, so the model learn to reduce the error. Then we predict just multiplies x with the learned theta to give final numeric output. After it, in logistic regression, in init, we again set the learning rate and number of training rounds. Logistic regression uses the sigmoid function, which convert any value into a probability between 0 and 1. After it, in training fit, we calculate predicted probabilities using sigmoid. After it, the fourth step is we compute the gradient based on difference between predictions and real levels. And in fifth step, we're just doing after learning theta, predict uh, probability gives probability and predict convert it 0 to 1 based on threshold. Here you can see. So this program doing all these things, and we can run this program, this Python program, for calculating accuracy, precision, recall, specificity. All we can calculate using this program. This is the whole program that I am showing on screen. This is whole program. This is part one for it, and this is part two. After it, the question number 9 is write one hot encoding for the given data. For given data, we have to write one hot encoding. Apple 1, mango 2, apple 1, mango 3, and here the prices of apple and mango and orange. So, one hot encoding idea is what one hot encoding convert the categorical column fruit into binary indicator column. One column per category. Here the categories are apple, mango, orange. We create three columns: fruit apple, fruit mango, and fruit orange. Each row get a 1 in the column for its fruit and 0 elsewhere. So the resulting one hotted table is fruits names apple, mango, apple, orange. Then value of fruit and price is given. Then fruit apple, after encoded 1. Fruit mango is 0 and fruit orange is 0. So this is the encoding 0 1 0 0 1 0, 1 0 0, and 0 0 1. So this is after encoding that which fruit exists in that particular row or column. After it, notes for this. This is the standard one hot. If you want to avoid collinearity in a linear model, you can drop one column and keep only fruit apple and fruit mango and infer orange when both are 0. Value of fruit appears numeric and redundant with categories apple is equals to 1, mango is equals to 2, orange is equals to 3. If value of fruit is simply an encoded form of fruit, you normally either use the one hot or the numeric encoding, not both. After it, question number 10 is why KNN is considered as lazy learning. Discuss K nearest neighbors. Consider the following table. It consists of the height, age, and weight value for 10 people. The weight value of ID 11 is missing. Predict the weight of this person based on their height and age. So this is height and age is given in the question, and weight is also, and the ID of the persons. So according to table, we have to find So after it, why KNN is considered lazy loading? Because no model building step is here. So during training, KNN only store the feature vectors and labels of the training examples. There is no parameter fitting or creation of a compact predictive model. Computation is deferred. All heavy computation, computing distance, sorting neighbors, aggregating target, happen at prediction time when a query instance arrive. Contrast with eager learners. Methods like linear regression or neural network perform training to compute parameters or weights. Before prediction time, predictions are then cheap. KNN delay this work and is therefore called lazy. After it, practical implementation. Training is fast, but prediction can be slow and memory intensive for large dataset. Also, KNN's behavior depend heavily on feature, scaling, and choice of K. K nearest neighbor algorithm for regression. Give a query point x q x and q x q. Compute distance d x q x I d x q x I d x q x I to every training point xix ixi. Select the KKK points with the smallest distances and predict the target as uniform average. For this is formula that is showing on screen. After a distance weighted average. For this is the formula WI for weighted average. After it, return y, whatever your output is. After a numerical prediction for ID 11, height is equals to 5.5 and age is equals to 38. So we have to find out this 5.5 for 5.5. So uh, here given training data, this is the training data, this is given, and height is 5.5, age is 38. We have to find out. After it, standardization, we can for standardized distance to ID11, this is the output of whole, and we can compute it using z is equals to value minus mean divided by std using the training data. Distance is z space rounded. Using this, we can find out this. Nearest neighbor, standardized sorted by distance. First ID 10, weight 58. Second ID 6, 60. Third ID 3, 55. Fourth ID 4, 59. Fifth ID 8, 60. Now predictions K is equals to 1. Predict weight is equals to weight of nearest neighbor is equals to 58. K is equals to 3, average of nearest 3 weight is equals to average 58, 60, 55. K is equals to 5, average 58, 60, 55, 59, 60 is equals to 58.4. This is all about these three questions. Thank you.